This is another lecture for the analog modulation. Apart from this, already we have about amplitude modulation. Okay. So this is in case of analog modulation, we'll see that how we have different two types here. Okay. That is the phase modulation and frequency modulation, how we can obtain frequency modulation from the phase modulated signals, as well as how we can obtain the phase modulated signal from the frequency modulated signals, and what is the standard equation of this modulated wave in both situations that we are going to see in this part. So let's begin with you already know that in case of when we are talking about the modulation, so two signals are required. One is the carrier signal, another is the message signal. So message signal is also called as the baseband signal or modulating signal. So in case of angle modulation, the carrier wave is going to change, okay, as per these angles of this message signal, as per the instantaneous value of the message signal, but here amplitude will be constant, okay. What is will be constant? Amplitude is constant. And it can provide better discrimination against the noise and interface, since here amplitude is constant, so it will be less affected by the noise, and it is going to utilize the more transmission bandwidth. So now here we have basic concept. So still you didn't subscribe our channel, please subscribe it, share with your friends, write comments, like it. So basic concept of angle modulation here, we are going to consider the instantaneous value of the angle, that is theta I of t. It is the angle of the modulated sinusoidal carrier. So when carrier is modulated, so with which is the function of the message signal here. So in case of angle modulated wave, the standard modulated signal is given as AC cos theta I of t. So where theta I of this instantaneous value having period of 2 pi, like we have sine and cos, all these things. So this theta I of t is going to increase monotonically with respect to time, and here this frequency, whatever we are going to take, that is in the hertz. So this particular interval of time, how this value is going to change, t to t plus del t. Okay, del t is the small interval of time. And here you see that we are going to use the concept of limit, and then we'll find the value. So now this frequency is the here f del t of t, this function of t here. So that is given as theta I value at t plus del t minus theta I value at time t divided by 2 pi del t. So this instantaneous frequency, we have fi of t. So that fi of t is the limit when del t tends to 0 of the equation 2. So finally, if you see that, this is going to take the pattern here of the limit, like we have another expression where you are saying that when we have function of a small change t plus del t minus function is t, and you are going to divide by del t, then it is going to give us the differential of that one. So like if you have limit, okay, this limit value where here del t tends to 0. So if you have any function that is like here t plus del t and minus f of t, okay, and you are dividing by del t. So this is the just as the when we are going to differentiate this function with respect to time. So that's why we are having the value here. 2 pi is taken outside. So we have 1 by 2 pi d theta I of t by dt. So that is the relation from the limit. So in case of unmodulated carriers, this angle theta I of t value is what? This is the 2 pi fct plus phi c. Okay. Where phi c is the value of theta I of t at t equal to 0. Okay. At particular instant when system that operation is going to start, that we call t equal to 0. So that value is here phi c. And this phase relates with the angular velocity, that is the 2 pi fc. Fc is the frequency, that is the carrier frequency. And there are various ways in which theta I of t is going to change. But here only we are going to consider about this on the basis of phase and on the basis of frequency, how it is going to change. So let's see first about phase modulation. Okay. Any doubt is there? You can write in the comment box. Okay. So phase modulation. Now name itself is what? Phase. So it is the form of the angle modulation in which angle theta I of t is varied linearly with the message signal m of t. So which is going to vary here? Angle. Okay. Theta I of t is going to vary linearly. So finally theta I of t is given as 2 pi f c t plus kp into m of t. So m of t is your message signal and Kp is the phase sensitivity of the modulator that is given in the radian per volt, and 2 pi fct is the angle of the unmodulated carrier. So like we are writing omega t, okay, so omega is what? 2 pi f. So in place of this carrier, it is the frequency is fc, so it's written as the 2 pi fct. In general also we know that omega is 2 pi f. So here what we are going to assume that angle of the unmodulated carrier is 0 at t of 0. So then finally we have phase modulated signal that is going to be AC cos 2 pi fct plus kp into m of t. Since already we have seen in the starting, in case of angle modulation, this standard equation is AC cos theta I of t. So here what is the theta I of t? That we got 2 pi fct plus kp into m of t. Similarly, in case of frequency modulation, name is what? Frequency. So what is going to change? So it is the form of angle modulation in which instantaneous frequency is going to change linearly with message signal. So that instantaneous frequency is here fc plus kf into m of t, where fc is the frequency of the unmodulated carrier and kf is your phase, that is the frequency sensitivity. That unit is what here? Hertz per volt. These are the importance. When we have numerical, there you'll understand the importance of this. So here m of t is what? Our message signal, okay? And then if you are going to integrate this, whatever we got here, that is fi of t. So after integration and by multiplying by 2 pi. So here like when we have multiplying both sides by 2 pi. So we have 2 pi fi of t, 2 pi fc and 2 pi kf into m of t. After that you are going to integrate this. So after integrating with respect to t, okay, so that is your theta I of t, and dt integration will become t, and again here this part m of t is being integrated over the interval 0 to t. So first what we are doing? Multiplying, or we can integrate. After that we can multiply by 2 pi. So we are able to get the equation number 8. So here we are considering the angle of this unmodulated carrier again at t equal to 0 as the 0, like how we have seen in case of phase modulation. Similar consideration we are doing here also. So this frequency modulated wave, again AC cos theta I of t. So already we got theta I of t value. So this equation you need to remember, that is AC cos 2 pi ct plus 2 pi kf integral of m of tau d tau over the 0 to t. So this is the standard equation of the FM modulated wave. So on the basis of that, if some equation is given of the FM modulated wave, how we can recognize the different parameters, that also we'll discuss with the help of numerical in another lectures. So here this FM signal, we have seen modulated, frequency modulated wave as well as phase modulated wave. So this FM signal can be generated by integrating the message signal, okay? And again, it is given input to the phase modulator. So first we are going to integrate the message signal, and then you are going to give the input to the phase modulator, then we'll get the FM. Similarly, phase modulated signal can be generated by differentiating the message signal, then it is given to the frequency modulators. So by the help of FM, we can generate PM. By the help of PM, we can generate the FM. So that is the discussion here. So you are seeing that this is the integrator message signal, that is the modulating wave or baseband signal is given input to the integrator. This integrator output is given to phase modulator. Another input to the phase modulator is what? Carrier signal AC cos 2 pi ct. So that is going to give us frequency modulated wave. Similarly, if you want to obtain the phase modulated wave, so that modulating signal is given to the differentiator, and differentiator output is given to frequency modulator. Another input to this frequency modulator is what? Carrier signal AC cos 2 pi ct. So here integrator, phase modulator is coming together, and again differentiator and frequency modulator is coming together. So DF, differentiator, frequency modulator. Here we have IP, integrator and phase modulator. Okay. So in the both case, in case of FM wave and PM wave, we need to know the standard equation like we have seen in case of amplitude modulated wave. That also we need to keep in the mind. So this is the important concept about angle modulation. Later in another lecture, we'll see in detail about frequency modulation and all these things. Okay. So please like, share, subscribe. Thank you. Thank you very much.